Hello, my name is Nick Morris. This is a presentation approximately 10 minutes long, and it's associated with big data benefits and opportunities at the bank that I'm presently employed at. The big data goal. The bank is looking at big data to gain analytical lift to their existing predictive analytic processes. The primary focus is log files that can be written to Teradata in the form of a blob. It's difficult to analyze and build predictive models from blobs, however, and other unstructured data sources. The end goal is to have an environment that supports parsing, text analytics, and keyword lookups. Sound data capture preparation techniques lead to knowledge extraction and pattern matching through predictive analytics. For example, classification models, clustering, association models. These conditions make it necessary to integrate unstructured data with the bank's rich structured data. Actually have an extensive data warehouse that's running off of Teradata. So Hadoop, this is where Hadoop comes in. It's the tool that allows the bank to achieve its big data goal. It was originally designed to store various types of data for companies like Facebook. However, Hadoop isn't a single source solution for the bank. It augments and complements Teradata. It's important to note that the bank has a rich and extensive reporting environment out of Teradata. Additionally, the security, the accessibility, the integration, and the performance that Teradata offers can't be replaced by Hadoop, at least not in the foreseeable future. Teradata Unified Data Architecture. Okay, I'm going to spend a little bit of time on this slide, and it's fairly busy, so I'll take my time as I move through it. You know, how do you pull all this structured and unstructured data together? Well, this is one solution. I feel it's a Cadillac of architectures, and it's the Unified Teradata Architecture. 3 data analytic platforms are all integrated into one. I'm going to start in the upper right hand corner right here with the orange oval. That's actually Teradata, and that's in place today. This is our integrated data warehouse that supports all our existing reporting and analytical needs. It allows self-service business intelligence reporting, ad hoc analysis with SQL. There's security and excellent performance from parallel processing. It's something we implemented about 3 years ago, and we're very happy with it. Okay, let's go down to Hadoop. This is in the green oval. This is the new platform that we want to integrate in with Teradata. This is where the data. This is where we store the data that is too large and or not compatible with Teradata. It captures the various types of unstructured data needed for parsing, text analytics, and keyword lookups. It could also handle imagery, spatial, and voice data. And you see the arrows down here that are really kind of speaking to those sources and how it's fed into Teradata, or I'm sorry, Hadoop. Additional benefits are as follows when we're talking about Hadoop as it's associated with the unified data architecture. It's really Hortonworks data platform, which allows users to get up and running very quickly with big data analytics. They've taken the open source software from Apache and made it easier to install. Hortonworks also supports Hadoop and provides higher level of security than straight Apache. They've also synchronized parallel processing between Teradata and Hadoop with Yarn to maximize performance. Also, Hortonworks, again, they've worked with other vendors to integrate their data management tools. So that's the Hadoop piece. What I want to move on to next is Teradata Aster. And this is over here. It's in the upper left-hand corner. It's the red oval. And this is really the discovery piece of the platform. It's the exploratory platform for our users. It allows prototyping analysis for business users on the data that's in Hadoop. For the most part, users are preparing data for analysis on this platform. This is where the voice and imagery data in Hadoop is converted into categorical or numeric representation prior to running it through their data mining algorithms. Now, on a technical note, developers push highly expressive SQL MapReduce functions written in Java, C++, and R, for example, into Aster, where the analysts invoke these functions with SQL, R, and SAS. This is where the ease of reporting comes in because analysts are using tools that they're familiar with. The output and data can then be further consumed by SQL or written to tables and moved over to Teradata. It's just a total integration piece. Move on to the next slide. So unified data architecture, why not? Well, it's difficult to implement UDA because of the high costs. So the next best approach is to experiment with prototyping. We've taken advantage of open source software and cheap hardware at the bank, and that's what I want to review with you next. We're actually capturing big data in Hadoop, and we've also set up parallel processing with MapReduce. We're currently doing that. And we're experimenting now trying to integrate data sets between Teradata and Hadoop. The most intelligent way to tackle big data is to show value through experimentation and then calculate the total cost of ownership for unified data architecture before investing in it. You really know the full-blown integration big data platform is expensive when you can't ballpark it without contacting Teradata. It's just really hard to get the numbers on this. However, this architecture is really only necessary if the bank plans to aggressively move toward big data, mainly building new products and services with big data. It's important to understand the limitations of prototyping. For our current Hadoop cluster, it's just a prototype for driving out the value of unstructured data. The real processing and storage value comes from a server-based solution with commodity servers. Secondly, the Teradata connector is an experimental tool because it's command line driven and not optimized for performance. The next step is to evaluate Teradata's query grid, which has a SQL interface and much shorter response times. Okay, the portfolio of big data initiative. The bank should build out a responsibility matrix that engages as multiple aspects of the company, as outlined by the following chart. Management should evaluate the data internally, also driving out the business needs. The quick hits will come from what's available in the data now. The longer term approach is figuring out and prioritizing really what's needed. And you can see our strategy covers everything from cost savings to better decisions and product and service innovation, which is really the most aggressive approach. But I think in the early stages of big data analytics, we should be looking for the quick hits. Big data initiative and opportunities. Cost savings opportunities, as I alluded to in the slide before. Lower storage costs by moving Hadoop to an archive solution. We save off about 5 years worth of data in our level 1 reporting environment. It would be nice to move a big share of that off to Hadoop, or maybe we could even save up to 10 years by taking that data and moving it to Hadoop. And also better decisions, augment predictive analytics with external data, develop fraud prevention and analytical techniques with particular usage patterns found in transaction data. I don't feel today our bank is doing a very effective job at doing this. We actually have employees that spend a lot of effort and manual time identifying fraud, and sometimes they have individuals working all night. Also, product and process development, improve target marketing by achieving a greater understanding of the multi-channel customer relationship journeys through the web call centers, FSR interactions, revealing impacts to attrition or product service purchases. We call this the golden path to purchase. This is what the really big banks are starting to do, and I think our bank really needs to focus on this. And additionally, it's important to understand what competitors are doing, like I alluded to. Bank of America does this, and Citigroup, they're also working to understand their customer. They're identifying credit risk by comparing purchase and payment patterns between commercial and consumer cards. And they're also providing dynamic digital offers to customers' mobile devices. All right, the top 5 must-haves for making big data successful. And this is probably the order of importance, of course, 1 being the most important. Hire, develop, and retain employees that have a passion for developing big data solutions. Data preparation and mining skills are imperative. Tie big data initiatives to a specific goal or task. Avoid capturing and storing big data without a plan. All the experts are saying that. Keep executives informed on our big data progress and industry trends. It's important to note that 80% of IT projects fail to meet expectations. Identifying the real needs of the business allows you to reduce this failure rate. Then adopt a big data mindset. Allow experimentation and fail fast. Go for quick, small value hits rather than big paradigm shifting initiatives. Focus on speed to market and agility. Focus processes on gathering, analyzing, interpreting, acting on big data in real time. And number 1 must have is allow employees time to commit to big data solution. Nothing happens without human resource allocation. Thank you. That's the conclusion of my presentation.